Alright, so in this video, I'm going to talk about properties of logarithm. So there are a couple of properties that is going to be very important, something that we're going to use when we come across logarithm problems, log problems. So the first one is going to be product law. So as the name suggests, so this is going to be used when we have product of two functions in terms of logarithm. So here what happens is that I have log a and my function x is being multiplied by y. So because they are product to each other, what happens is that I can actually separate them both and it's going to be a plus. Alright, so here I have a base of a. So what happens is that when I separate them, both of them is just going to be a separate log with the base of a. So it's just going to be log x plus log y. So that is going to be the product law. And then I have the quotient law. So quotient means fraction. Okay, and for this case what happened is that I have a function of x over y. So therefore, according to the quotient law, so when you have x over y, when you separate the log, it's going to be log of ax minus log of ay. So the base is still going to be the same. So they are both going to have a base of a. Okay, however, I would like to remind you about this. Okay, so if we have seen in the formula, so log a of x over y is equal log ax minus log ay. However, so these two, they are not equivalent. However, if you have log ax over log ay, meaning that for this case, they don't share the same log. For this case, they share the same log, but this one, you have a separate log at the top, separate log at the bottom. So it is not equal log of ax minus log of ay. So please bear in mind about this, okay? So these two, they are not equivalent. They are not the same, okay? When you come across them like this, so please do not use them quotient properties or the quotient law. And then we also have a power law that states that if you have log ax to the power of n, so this is going to be the power. I have n as the power of x. So what I can do is I can actually move the n to the front of the function. So it become n log ax, for example. So let's say if I have a log of a 2 to the power of 3, I can move the 3 to the front. So it's going to become 3 log of 2. So base of a. So that is how it's going to look like. So all we do is, so the power becomes the constant at the front. So that is going to be the power law, and we can also change the base. Okay, so if you notice previously we have been using the base of a. Okay, for this case I have base of b and I want to change it to a base of c. Okay, so I have b, now I'm going to change to b in terms of c. So what happened is that if you notice, so here I have a at the top, b at the bottom. So when I change the base, so what happened is that a is going to be at the top over b is going to be at the bottom. But now my new base is going to be c. So I have c as the base for both of them. So this is what happened when you change the base. For example, so let's say if I have a log of 5, and instead of having a base of 2, so I'm going to change it to be a base of 10. So what happened is that I'm going to have log of 10 at the top and another log of 10 at the bottom. So this one goes on top, this 5 over here, it goes on top. So therefore here I'm going to have 5 at the top. So 2 goes to the bottom. So therefore it's going to be over 2. So when I change log 5 in the base of 10, so it will become log 5 base 10 over log 2 base 10. So that is how it goes, right? So that is called as the change of base law. Okay, so there are also like other properties that is important for you to know in order for you to do log operations. So the first one is when you have log of 1. Okay, it doesn't matter over here, so it can be any base. So let me put over here for any base. Okay, so whenever you have log of 1, so the important point is that it's going to be 1 over here. It is always going to be 0. So if I were to give you an example, so let's say if I have log of 1. So we know that when I write log of 1, so this means it is log base of 10. Okay, but I simply can just remove the 10, and we know that log 1 is simply log 1 base 10. But here we know that what happened is that whenever you have log 1, no matter what is going to be the base, this is simply going to be 0. Or even if I have ln of 1, so this is going to be 0. And as I have mentioned in the previous video, so what happened when you have ln, this is actually log base of e. Still, even if we have a base of e, so this is still going to be 0. Sorry, this is not 10, so this is supposed to be 0. Okay, or if you have a log to the base of 2, 1, again, it is still going to be 0. So the main point is that whenever you have log of 1, it is always going to be 0, no matter what is going to be the base. And the second important property is that when your base and the value that comes after the base is the same, so that is going to equal 1. So if I were to give you an example, so if I have a log of 10, this is going to be 1. Why is it going to be 1? Because I know that whenever I have log and it's not written what is going to be the base, this is actually log 10 with a base of 10. And according to the rule, when these two are the same, it is going to be 1. Or if I have a log of 2, 2, when both of these are the same, okay, so this is going to be 1. Or if I have ln of e, so this is also going to be 1. Why is that so? Because we know that ln stands for log to the base of e, so therefore I'm going to have log e, so that is also going to equal 1. So remember, I did mention to you also in the previous video, so the fact that e is just a constant, it's actually a value of 2.71 something. I don't remember the rest of the decimal places, but it's a value of 2.71 something. Okay, so whenever you have the base and the number right next to it, here they are the same, automatically the log is going to equal 1. Okay, and let me put a paper over here so I can actually explain to you the other two. And here I have a property concerning power. So here I have exponent a raised to the power of log ax, and that is going to equal x. So if you remember what I mentioned to you before, so index and logarithm, they are the inverse of each other. So let me put over here. So index and log are the inverse of each other. Okay, for example, if I were to have a positive of 2 constant, we know what is the positive of 2. The positive of 2 is going to be minus 2. So what happens is that when I have plus 2 minus 2, they are going to cancel each other, so it is going to become 0. Okay, and the same goes for the case of product. So if I have a 2, so I divide that, so that's not going to be the same. Okay, for example, let's say if I have 2, I multiply that by a constant a, and I know that what is going to be the opposite of a constant a. So the opposite of the constant a is going to be a division of a, so it's going to be divide by a. And what happened is that, so these two operations, they cancel each other, and I end up with the original function, which is simply going to be 2. Okay, so whatever that comes, if it's the same, one is product, one is division, they are going to cancel each other. So this is going to be the same for index and logarithm as well. So what happens is that if you have them together, so they can cancel each other. So this is what happened over here. So if you remember, if I have an index, so whatever that goes underneath, this is called as being the base. For example, if I have 2 to the power of x, so this 2 over here is called as being the base. And whenever I have a log, so whatever that goes here, so this is going to be the base. If you notice, what happened here is that, so I have a as the base for the index, a as the base for the log as well. So what happened is that they can cancel each other. So this operation is going to cancel each other, so it is going to become x. If I were to give you an example for that, so let's say if I have so the easiest one is going to be, let's say I have 10, and then I'm going to have 10 to the power of log 10 of 3. Okay, so what happened is that this index and log operation, so it's going to cancel each other, and I'm going to end up with a constant 3. However, so if you ask me what is the common use of this, is going to be when we have exponential. For example, if I have exponential of log 2, so this is where it is most common for you to use this operation. So what happened is that exponential and log, we know that they are the opposite of each other. Why? Because ln, so it's actually log to the base of e2. So what happened is that these two, they're going to cancel each other, and I'm going to end up with a 2. Or it could also be the other way around. So here what happened is that I have the index at the bottom. Okay, so I actually need to add another one. I add that later. So what happened is that this is going to be the case that where you have index at the bottom. This is my index, and logarithm at the top. It also applies when you have it the other way around. For example, so let's say if I were to have something like this. So I have log of exponential of x. So what happened is that these two are going to cancel each other, and that is going to become x. Why? Because log of e, so that is going to be to the power of x. So this is going to become x. Or you could also think about it as being x log e to the base of e. So for which this is going to be 1, and that is also going to become x. So remember, so the main point that I want to deliver to you here is that the fact that the index and logarithm, they are the inverse of each other. So they cancel each other. So how do you cancel a power? So you log them. Okay, so this is what happened. Right, so these are going to be all the law of logarithms that we're going to use. So both of them, the properties that we have seen over here, all these 4: product, quotient, power, change of base, and then this properties as well. The fact that when you log 1, it is always going to become 0 for any value of the base. That when you have the base and the number that goes after is the same, so your log is going to become 1. And the fact that the index and logarithm, they are going to cancel each other. So I want you to bear this in mind, because this is what we're going to use. So I'm going to start with example number 1. Okay, so the question says that this is very common when you come across question in terms of log and index. So we're going to tell you without using a calculator, because we know that it is possible for you to use a calculator to find this. So therefore, when you come across something like this in test or exam, when I say without using a calculator, please don't simply like write, okay, this is going to equal what value, because you simply get from the calculator. No. So meaning that you have to show some certain calculation in order for you to achieve that answer. So I'm going to start with question number 1. So let's put over here question 1. So I'm going to start with a. So what do I have for a? So I have log 28. So what does the question ask me? So I have to evaluate the following. Evaluate means like from whatever that we had, we have to find one number. So now I'm going to start simplifying this and find one number over this. So first of all, when you come across something that you need to simplify and evaluate like this, so you have to find a relationship between both of this number. Okay, so of course there is a relationship between 2 and 8. So how are they related? Because we know that 8 is equal to the power of 3. So now what happened is that I'm going to use the power law. So the fact that when I have a power, I can actually bring that to the front. So this is what I'm going to do. So this is going to simplify to 3 log of 2. And you have also seen this before. So the fact that when I have a function that looks like this, the base and the number that comes right after is the same. So I know that this whole thing over here, log 2, this is going to equal 1. So that is why log 8, this is going to equal 3. So that will be the outcome. Okay, so that is going to be for A. And then let's proceed to B. For B, I have log of 9, 1 over 81. Log of 9, 1 over 81. So it's going to be the same idea. So what I have to do is I'm going to have to find a relationship between the 9 and also 81. And the good news is that there is a relationship between them, because 81 is actually 9 to the power of 2. Okay, however, how would I simplify them? So I'm going to change this fraction over here. So instead of writing as a fraction like this, what I'm going to do is I'm going to bring that up. So we know that we have seen this before from index property. So I'm put over here. So this is an index property. So the fact that when you have 1 over x to the power of a, so this is equivalent to x to the power of negative a. So when you have the power underneath, when it's underneath, it's positive, when you bring that up, it is going to become negative. So that's what happened over here. So I'm going to use that property. So this is going to become log of base 9 to the power of -2. So previously it's a value of 2. When I bring it up, it's going to be a value of -2. So here I'm going to simplify this further. I'm going to write that this is going to equal -2 log of 9, because remember, this is the power and you can bring that to the front. So when I simplify, so this whole thing right here is going to be 1. So therefore, I will end up with -2. So basically, log 1/81 to the base of 9. So that is going to equal -2. So that is the second example. And the third one, what do I